So hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 229 and in this video we continue with our exercise. And in this video I want to go to the next function, which is our search name. We have finished this create linked list, we have finished this sort score in our last videos, and now we need search name. So, and I already coded this one. I hope you tried it on yourself too, because that's the reason why we make exercise. You should try yourself first. Try, even if it's not working, just try it. So you repeat the keywords and all this kind of stuff. And I show you my solution here. But I have actually two solutions. One is not optimized and one is optimized. The not optimized version I want to show you here. And this is this version here. It's just one function. You can see it. This is this one here, this function here. And when I open this up, this you will see something strange here. Not the code itself. Look, this indentations here, this bodies. There are many nestings, right? And this is bad in general, because many nestings means it's a little bit hard to read and try to analyze the logic. So normally you would try to avoid this. But the point is, I said I have two solutions, right? This version was my first version, and the second version, which I will show you here, it's this version. You can see it's the same code. I have cleaned it up, and you can see there are only 3 levels of nesting max here. Think this it's okay. A little bit nesting we probably need, but not this kind of nesting. So the information which I want to give you here is that at start, when you start developing, this nesting of many levels are sometimes more logical than have a finished product like this. And the reason for that is, or what I mean with that is, most time you don't come up with the perfect solution like this one. Later you can optimize this nesting, which means you can change the positions, you can rethink what you did here, and then clean it up and make it more readable. But most time it's not easy to come up with the solution when you are developing. And I want to show you this now here. So let's get started and read a little bit the worst solution first and then the good solution. And here is my sort algorithm. So let's repeat also some keywords and functions. So you can see I created here a function, no return type. I called it search name because we are trying to search name. And in my single linked list, this one is not really needed here. But let's say you have here not only a single linked list, let's say you have different kind of lists, then you can add this info as well here. If not, if you have only one list, then you would just say search name and that's it. And then you can see here I used again parameters. We talked about it. Interesting is when you see parameters, if you need a const reference parameter or not. In my case, you can see I am not using a const reference. You know what this const reference is again? When we use normally const reference, that we talked about a lot about this one, and you see this a lot in programming, and you will see this most time when they are using here custom types. So which means custom means you are created your own types, like my node type here on top anywhere, or any other type which you created. And the reason is this kind of types are most time very, very large. So could be large. We don't know. The programmer don't know, because I don't know if the type is big or not. Then they use this const reference to avoid copying yes, this variable here, which will create here a copy. When I pass here in this function the argument, this one will create a copy of the string. But string here in my case, I'm just searching a name, and names are only some letters, 5, 10 or around this numbers, and this is very string. So you can go on if you like with just a normal copy, but if you say even that you want to avoid, you can still go with const and reference. Let's make this, and this is also not wrong. So this is just avoiding a copy. All right, with that said, you can see that we have created now the function. And I have only here one function, and then here I have many if checks. And the first thing what I check first is here, is there a score list? And if there is not a score list, you can see the else part, then I will just print out there is no score list. And the keyword return means just go back to the function caller, which will be here in my main, because in my main I will call this function. But before I call this function in my main, you can see I need ask the user first to write name to search, right? So I print out first a message, enter the name you want search, for example. Then I create a variable where I want save the variable which he or she is entering. Important is here you can see already this declaration here of a variable is bad style, but it's not wrong, it's just bad style. Then normally when you create a variable, just create it most time with a default value, and a default value could be something like this. This is just empty, but still then you know this variable has an empty value in it. That's just to make it better, so we repeated this as well. And here this function, you probably know it, getLine, is used instead of std_cin. Normally you can get the user input like std cin. This is the opposite of cout, by the way. This one is output. Cin would be this one input, but we learned cin is not good, and the reason for that is cin reacts on one word without spaces. If you have here space, then it is not taking this one. It is taking actually the other word, but for the next cin buffer, and cause problem. Instead of that, I talked to you, it's better to use just the function getLine. This function will use std_cin, but it will save the whole line, whatever you entered in this variable, which we just declared. And then you can see I use this variable to call my function. So here I call my function. We go back to our function. I don't have here the marker, but here I go back. And like I said, if there is no list, again, I use a return, which means just go back here to the caller and continue with the code. And here is nothing. It will return and stop the code. All right, that's this. But here again, to make it a little bit more visible, let's make here faster paint again so we can see it, what I'm doing. It's a little bit easier to follow sometimes. So what I do here again, I just check if here is a node, because we know we need, also in my case, I need a node with a head, because the creation of my node, I create this in the memory. I allocate this one, and when I allocate, I need this head pointer here, which gives me access to this place. And here, this score list head, I just check if the score list head is yes, if this is true. And this version here, what you see here, it's interesting because normally we write something like this one here. Let me show you this. Normally we would write not this one here. This is the normal check, but you can see this is not working. And the reason for that is this one is a pointer, this one is a bool, and you are trying to compare a pointer with a bool. And then when I hover my mouse over it, it says, yes, you are trying to convert incompatible types. And the question is, okay, this one is the real thing what I do here normally, but why is this one here working? It's a little bit strange. This is still a pointer, and this one here of the if condition, it will convert this in a bool. So here important is that you know this is again this implicit conversion. That means the compiler behind the scene can convert a pointer to a true or false value, which means this pointer can be converted to a bool, but it is doing again behind the scene. We talked about implicit and explicit. There are some problems. Sometimes you want it, sometimes you don't want it. This is the case where I use it, I want it, but sometimes you don't want it. These implicit conversions, which can cause sometimes problems when you have, for example, there are some numbers and you don't want that they are converted to other types, for examples. this kind of stuff can cause problems. But let's continue here. So here, implicit conversion of a pointer is possible. That you should remember this. They are using this a lot. I use this here too. And then I say, okay, if there is a pointer, so if I have this head here, then you can enter this code here. Then I know I can try to find the name which was entered here as the parameter. Let's try to find a name. Let's call the parameter name here. Let's say we try to find name param is here Maggie. Let's try this one. And then I say, I can now enter to the code section where I try to find Maggie in this node. So we go there. So what I do next is very simple. I create again a new pointer. And here we talked about creating a pointer. What kind of pointer is this? Careful when you read pointers. Pointers are just variables like normal variables, but they are pointer variables. Interesting is that you don't confuse all time pointer with memory allocation, because sometimes many people think pointers have all time to do something with memory allocation because they are used most time. Let's say when you allocate memory, you need pointers. This is a requirement. We talked a little bit about this when we, for example, create this node. The return type of memory allocation with this keyword new requires a pointer, but pointer is just a variable. And in this case, I just create a pointer variable, which means I can use it just as normal variable. And my use case is I want just that it points to where this head is pointing. So I create here a pointer here, this one, and I call it, let's call it iterator. And then what I want to do is, the reason is, wait a minute, why you are creating a pointer? Because this pointer is the thing which I want to get here the information of this node. So because I need a way to get the information, because here the node has here a variable called name, right? Saved here anywhere name. And for example, it could be the Maggie or Coda or anything else. And this pointer can get this, and we know this. You just create a pointer and then you specify the variable which you want to access. For example, I want to get this name here. Let's make it big. So name here. And now I can do something with that. And what I want to do is I want just compare it with the input name param here, right? Which should be, for example, my Maggie name param. Oops, name param. Okay, you get the idea, right? This pointer should just get the name, and then I compare it with it. This is my idea here. And so that's why I create the pointer. And important on pointers again, they are a little bit different like references. You can assign directly the thing what you want to use. In my case, I can assign, for example, here pointer directly to this node here, because I already know this exists. We have checked it here. If this would not exist, it would go here to the else statement, and I could not even enter here. So this was the check place. And the next point is here. You can of course assign a pointer with a null ptr2. We did this a lot when we created here other pointers with null ptr, but in comparison with references, let's say this would be a reference, you can't use a null ptr, which means you have to use something like this. You have to find an address where you want to get it. Just as a reminder, so pointers, this one is a normal pointer, no allocation of memory. You can see I do nothing with new. I just say point to this address of this score head. This one is a pointer, point also there. But you don't have to use a pointer. You can also get it from a variable. We know this as well. How you get it from a variable again? Let's say I have here any variable, then you would use this, just a reminder. If you have here any variable and you want point to a variable location, you would use the ampersand and the variable name, because you want to get the address of the variable, right? Remember, normal variable. So just as a reminder, because we make here also a little bit code repetition. All right, I hope you remember all this kind of stuff. We talked this, and let's go on here a little bit. So here I created now my pointer. The next step is This is still the bad code, by the way. That's why we go here deeper and deeper. And then you can see I said, okay, after I created this one here, I can say, first of all, I know I have to do this operation because I want to compare now, because with this pointer, I can get the name and then I can compare. But this operation, what you see here, I have implemented here at this one. This is the first thing. It says name iterator pointer name. I get it. And then I check it with name param here. And then if this one is the name which I wanted, let's say I'm trying to search this name. If this was saved here, then I just print out info on the screen. Yes, I found the name. And then I want to stop this execution here. Interesting. And here I use a break. So when we watch this break, this is here a little bit dangerous if you don't consider not one situation. This break here is used for the while loop, which I have not talked right now. And the question is why I need first a while loop before I go to this comparison. The reason is very simple. If you have if you have only one node, then you don't need a while loop. That's why I showed you this code directly. But let's see, you have here more nodes, which means your list is a little bit longer. And we learned when the list is longer, you have to find a way to loop through this list, right? And when you hear the word loop, there are different kinds of loops, while loop, for loops, or whatever loop you want. And then you know, okay, this is one way to go through a list with a loop, any loop which you like, which works for you. And a while loop works in my case. And that's why I created here the while loop. Here I said while, and again here, this one, again, I just set the name iterate pointer as long as this is true, which means I'm pointing to a node which evaluates to true, which means there is a node. And interesting is if there's pointer here would point to a null pair, because every last node has a null pair included in the node. We talked about this. If this pointer would point now to a null pair, this one would be false, right? And that was this implicit conversion. Careful about this, that you understand this all time. It is not, yeah, like I said, sometimes it's convenient, sometimes you don't want it, then it's absolute bad. But here I want it. I just check my while loop. So back to the code. First of all, I assumed, okay, if I have just one node, I can check it directly. If I have not one node, I need a while loop because I have to find a way to loop through this one. This is this while loop. So, and back to our break, why I said you have to consider here one thing, because let's say I find here my node, let's say I find Maggie, then I said, okay, I found it, I messaged it, and then I said break means stop this while loop. But careful, this break means only stop this while loop, not the function is not finished. What I mean with that is when you use a break here, it will just go here, stop the while loop, it will jump here and continue with the code here, which will be, there is nothing, okay. In else, it's going not in else state because we was in the true state, that was okay, and then it jumps here away, here down, and then it executes. But because I have here nothing, there is no problem. So my break would work here, but this break here is actually wrong. If, let's say, if there is anything else here behind here, anything, this one would be also executed behind the scenes, and you don't want this. No, what you want normally is here. Break is good for stopping this one, but you want also normally a return because you want to stop the whole code. But in my case, it works. Like I said, I have nothing after this one here, no code, and then this code execution stops. But keep this in mind, that you make not this mistake to think, hey, I found now my code, I use break. This break is only for this while loop here, not for the function execution. So this one would continue like I said, after the while loop. This else it's not in, but if you have something here, it can make problems. So keep this in mind. In my case, it makes no problems. Like I said, no code. We can go on with break. And then this is the case where I found it. Again, the case, what is if you are not finding it? Let's say this is here trying to find, it's not found. And then what I did here is the else state. And then I said, okay, else, set the pointer which you have here to the next get the node's next pointer, which we defined the node for every node. Let me show you this one. Every node has this internal next pointer, right? We have defined this in our node class that was here anywhere on top. Okay, you know, I think it was here anywhere. Okay. You know, I show you this one here. Here I have it. So the node class here, you can see we have here variables, and one variables is a pointer to the next node. And this one, I mean, this one, this pointer, getting now again this pointer, which means I get this pointer where this is pointing, and my iterator will then move from here where this one is pointing. So this one can point to a node, to another node, or this one can point to a null PTR, right? Because if it's the last node, that's PTR. And let's say, and that's why I make here first, I set it to the next node. So first I get this pointer, you can see it here. And then I check in the next step if this is the null PTR, because the null PTR is an end condition. Null PTR means in a list, in a normal list, it's all time the last node. Like this is the way how I defined my list in a linked list. The last node has all time a null PTR. And when I search a name, I just need to go here, check for null PTR, then to try my check my comparison, go to the next, check my comparison, go to the next, check my comparison, and if I found null PTR, I know I'm finished. And this one, I made this with this one. And then I say, okay, if this is the null PTR, after you change to the position, you can see here, I try to, let's make it so, because here we see nothing. Let's make this one. Let's make this one more. Again, this one here, here, and here's my pointer. Here it goes here. Here's null PTR, and you can see if my pointer here is changing now to this position, it's pointing now here. So, oh, that looks awful. Yeah, I have to work on drawing a little bit, but you get the idea, right? So if I change to this position and then I just check if this is the null PTR, so I get here the next node. You can see this one is just getting here the next node. And then if this is the null PTR, I still have to check this node, right? This node I have, because here I just changed. This is this line. This is just the change to the next node. And then I check it is the null PTR. This is this line. And then I have still checked this node if here the name is, because I have evaluated this node as well. And this is that what I do here. So then I say, okay, get the name from here, check if this is the param. Okay, found, make again a break. Again, this break works only for a while, but I know after this I have nothing. And then else, if you found nothing, say it's not in the list. Here I say it is not in the list output. Very important. Why I say this one? Because this one was my last node which I checked. I went through the whole nodes. This one was my last node, and if I found it not till now, there is not. So, and now comes the point with this thing what I showed you, the good way and the bad way. So you can see this here is bad because I have here many nesting, but at the start I said when you develop, this one is more natural than the good code which I showed you here. The good code looks a little bit easier. You can see almost only 3 nestings here, not a big nesting. it's much simpler, looks even easier to read, but we have a problem. This one, when you read it through, it will be simpler, but from a developer perspective, the logical order is not the same as here. Because let me show you this again. Here, you can see it in this graph. Every time I do something, I know what I have to check. So I create one, I check this, and then I know after I have a null pair, I can check this, and then I can add this, and you can see all the steps I make in, I include directly in my code, and that's why I have this nesting. But here, let's try to repeat a little bit. First of all, I go here. Here I use already a trick. So the trick here is, that's interesting, there are two parts here which we have to discuss. The first one is this here. And here I showed you before, the first thing what I did here was here this name checking if we have a node. That was the first thing, right? The score list head must be true. That means there is something, and if it's not true, I said you can just make an output here. There is no list, and then return. Return means executing the finishing this function here. You're returning the function and continue through where you called the function, and I called the function here below, which means it will return continue here. So that's okay. But now the trick here is, which I want to show you, is here in the good code. Instead of using the positive value to check, you check the opposite. Here, I check if the score list head has a list, right? And if it has a list or a node, if it has a node, then I can make a comparison, all the things what I showed you here. And if it has not a list, then I can't do, and that's why I return. And in the good code, I say, okay, why we not just check here the opposite? If there is no list, so which means if there is no list, then you can just say return, which means the difference here is really just that the true part becomes here the counterpart of the test. Here you can see it, the true part here. I skip this part, and the false part here becomes here my true part. And how I make this, very important, here is a little symbol. Don't forget to do this. This ampersand, we talked about this. This ampersand means a negation. It's a logical operator, and it will make the opposite true. For example, like I showed you here, again, this one means in real this one here. That's a little bit now hard to see sometimes because this one is here, this one. And if you use an ampersand, you make this one normally. You make this one here. This one is that what I made here, because this one you can't do because here, again, implicit conversion and the ampersand. Sometimes it's hard for beginners to see because you have to get used to it. But after you understand this, it's nice. So I just check, oops. Let's make here Control Z, Control Z. And this one we don't need. So you can see, I just check here the counterpart. And the benefit about this is you say, okay, if there is no list, because if I translate this now, it means if there is no list, then just return and print out there is no list. And important is here again, that's I should say too. Important is that you use here this return keyword, because in this list here, when we go down, interesting is this, sometimes you don't see that there is a return value here. Why? Did you know why here it's not so important, but here it is important? The reason is very simple, or it's sometimes very easy to overlook. Here in my code, this part is the last part which you can execute, right? You can see the true part would enter this block here, this positive part. The else part would enter this one. So if I have no return here, the function will still go to this line, then to this line, and then back to the caller. So there would be no problem here, even if I have no return. But in my other code here, there would be a big problem if I have no return here. Why so? Because if you have no return here, the code would execute here the other things as well, and you don't want that. So here you have to use return, and here you don't have to use return, but it's better still to use return to indicate this should just stop the function. All right. And you can see what I did here is I skipped now the whole part here. This true part, here is no true part actually in this if statement. The true part means just continue with the code. And our point is here. Now you can see one nesting level is gone. This line here, this nesting line, I eliminated because I just used this one and then I just continued with the code. Here you can see it. I just used this and continued with the code, and there is one nest line less. But like I said, this is not intuitive because this one here is more intuitive, I would say, because you just check if there is a list. Yes, then do this one. But this one is the counterpart bit, and this kind of stuff you make all time when you are finished with the code. For example, you have nesting here, and then you can rethink if you can make it more readable, like this one. And there is another technique as well. I show you this one in my code as well, because you can see here, this is now, let's say we have finished this part here. That was the first part which I eliminated, one nesting level. Let's try to eliminate here one more nesting level. You can see this while loop here. There is one more nesting level, but of course we need to know something. And the nesting level which I want to eliminate is actually this if block here. So how I can eliminate this one, and the reason is very simple. Not simple, you have to think about it, but simple to solve. The point is here, I started here this while loop, and the while loop checks first if the player name is here, right? And if it's, the player name and the name param, if they are equal, so I check this one here. And if they are not equal, I said, I just iterate the pointer to the next step. That was this step. And then I check again if this is the null PTR, because I have to check the null PTR, and then I will do again the whole step again. So I check if this is the name param, and if not, I make a break. And you can see, it's not easy to see for beginners because you have to think here a little bit. But after you think a little bit, you can see this check here. You don't have to check at this place. You can check this one actually when you start the while loop on top all time at the start condition. So and why you can make this, because if the start condition here says yes, this has a null PTR, so from start, then I can just check the name and make here a break. Again, this break is careful, it's just breaking the while loop, not the whole function. This can cause problems, and we will see this in a moment. But in my code, again, it's not making problems because, again, no code is coming after, but careful about the break. Break means only this for the while loop, not for the function. For the function, you need this, like this one here, something return, which means now you go out of this one, right? Here, but in my case, I use break because that was the first thing what comes in my mind. Okay, while go out of this and then check if there is code. Okay, I can keep it. Now, so important is now you can see first I check in my better code. Now I moved this one. Let's see. Sorry. So what really I did is I just grabbed this part here, this end condition. I grabbed it because this one was just a pointer to the next. And like I said, I need this check here on top only because I put it here. And you can see with this little thing, I eliminated again one level of nesting, because this nesting level from here is now placed here on top, and it's gone here down. Again, one level less. Sorry. So the important part is when you do something like that, it looks then better. It looks easier, and it will work, because here, again, you put the pointer to the next node. This is this state. Then the while loop is still true, which means it goes, here is no break. Important here, no break, because we are just moving it. And then I make the check in the next iteration. And this is anyway end condition. End condition means if this one is indeed the end in the next step, the break will work, which means we go out of this loop. And again, I repeat it one more time. You see the code here, which I made, looks a little bit better than this code here. Okay, now I have changed it, but let's make this one here back where I have not changed it. What is that? Control Z. Okay, perhaps here. I don't know what I did here. One more time. So here, so you can see this one looks not the, you can see how many nestings I have here. Nesting, 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 nesting. But interestingly is when you develop it, this one makes more logical sense because it describes the steps more clearly. But this code is later better because this one has less nesting, and when you read it later, this makes also sense. But the point is here already is optimized a little bit. It's optimization. And you need to do this in your code too a lot. Optimize your code, find it better ways, especially when you have nesting like this. You should try to avoid. Like I said in one time, nesting. Some nesting is not wild. So 1, 2, and 3 nesting is not so wild. But if you have something like this, can really hard to follow. Right, this operations, and if they become more and more complicated, for example, here I have just an easy check, right, and then I just outprint and then go out. But if this becomes more and more complicated operations, this nesting will blow up your mind, because you have to follow and target a lot of parameters, which you will not probably do in your head alone. But here you can see, here are still nesting, but it's more manageable, less manageable, because the blocks are more individual now. Very important. And I think I stopped with this one here, because now that was my search code. There is one more thing which I have to do, of course, to show you one more error. Comment. Let's do this one too. So I'm finishing this one off. Of course, you have test your code. And while I tested my nice code here, I found a problem, which I just mentioned here very short. The problem is, you can see I tried to make here a format, a user interface format to look it more better. I showed you that I make here spaces. And that's a problem when you are asking for a search string, because the player, the user, when he enters here a name, he will not enter, for example, let's try to find Maggie. He will not enter Maggie with 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. This was just for my formatting problem, so that I solved that looks a little bit clean. So all in one line. Make this so they looks all nice in my output, something like that. And then let's test this just for the purpose what I want to try to explain you, so that you can see this a little bit better. So let's say here's my login, okay, coder, my password A. Here's my sort, by the way. So here unsorted, sorted, and you can see Maggie is here, and I know it is in the list, right? I can see the name. And here it's still, and this one here is user interface, or GUI. GUI means GIU means graphical user interface, and so on. But we have not programmed this. This you make later after basics programming. And important is then how to present strings and then how to present in grids and all this kind of stuff. And you can see this cause now a problem like I showed you. Let's say the user is, like I said, the user will try to find, for example, he reads this list here and I'm interested, for example, here in Maggie. Let's write it. Maggie, and you will see I have a problem. Name Maggie is not in list. And the reason for that is very simple, not because my code is wrong, because this input, what I saved here, has spaces. Format problem. And there is in programming the string libraries and C++ as well. And there are billions of functions how you can format string, how you can space out get rid of spaces, and there are a million functions of string. So string, the library string is a topic for itself which you have to study, because string operations are very important in programming or in general, because you get information with string, you have file formats and all this kind of stuff. So we will talk about strings again in a separate video, probably after basics in libraries, because they are so important. We will talk about strings, some basics too, but only basics, not that one stuff. But here you can see this one cause a problem. So how you solve this problem? Yes, the bad thing is I can't use here my format which I want, so I have to get rid of the spaces, because no user will enter spaces, or you write your own converter that every input has a certain space for this or whatever. But this kind of stuff we can avoid with string libraries and string formation format later. But right now, let's do this again. Coder A. Again, I try to find again Maggie here, but it looks not right. But this, like I said, this is a job for yes, for GUI programming. And now I write Maggie, and this time found name Maggie in list. Yes, and this is very a simple found. I just say I found it, so there is or there is not. Of course, you can make an at once list where you can say output all the information, so you can see I just output that I found it. But of course, when you found it in the state, so let's say my code, I can change it a little bit. And found name, of course, you can here get from this one here also, because this is the found place. And then you can change this one here or this one. So we have to change it in two places, because one in the end condition and here in this normal condition. In this place, you should just add, for example, if you want get the other variable names. Let me show you what I mean. Copy this one, paste this one, found name, found class, and then you get name param, their name, okay. And then instead here, because here is already named param, then I can use the trick that I know this iterator is already on the right place. Then I can use here, this one here, name iterator pointer, and get me the class, character class, for example. Right? This one I can add, because here I already found the right name. And now I want just put out also, for example, the class. And then you don't have to search this separately, just you are already in the right place. The pointer is pointing to the right place, and just get all the other informations as well with this pointer here. And this is the thing which I use here in list. And let's see if perhaps I have to copy this line here on top too, because it could be also on the end position. So here, let's copy this one here as well. And this should, I don't know, I have not tested this one. I just wanted to show you that you can just get it fast. Let's see. And here, let's try find Maggie again. And you can see found name Maggie in class, found class mage in list. Yeah, okay, this output is of course this, but you see Maggie would be now mage. And yeah, this is something like that, which you can get and make additional functions and all this kind of stuff. But I hope you did a better job than me, because this one, what I showed you is, yeah, just for testing again, repeating keywords. And important is also showing that there are some things which you should avoid, or you can't avoid sometimes this actually. Like I said before, oops, let's say comment what I made here. Control uncomment, control uncomment. So what I want to show you is again here this nesting. When you start nesting, sometimes this makes more logical sense because the order is here more intuitive. This order looks better, is not intuitive when you are developing, but this one you can do later when you are finished with coding, and it's called you refactoring, you are changing positions, you are optimizing, you are the job which you are doing after you finish your code, because this code here works too. It is not wrong code, it is just too complicated. Could be complicated when you have here really complicated stuff. Just that's why you have to try to avoid nesting and make it simple to read. Even this has here 3 nesting levels, but okay, so far it's okay, I think. All right, with that said, if you have any questions, any comments, like all time, write it in the comment sections. And in the next video, I want to go to the next function. And this will be our insert function. Perhaps we make insert and delete at the same time, because inserting and we will see. We make first an insert function and then a delete function, and again I will make something like similar to this search name, not too big, not too complicated, just to show you that we can insert anyhow anything. Of course, you should try your own version, so don't use my version. It's anyway not the best one. Try your own version. Show that you can do it better, or show that you can do it worse, because that's also good. Then you can learn from the worse more sometimes, because you say, okay, this was worse, I can do this and change this. The most important part in programming is all time make it work, even if it's not working. Try to make it work, and then you learn a lot. All right, with that said, see you in the next video. Good luck and have fun. Bye.